Very good. Okay, so today we're talking about the data flow. So data flows from plugins to the processor, then back to the context, and then to the user. And the mailbox system is sort of, you could say, is sort of part of the processor. So the reading for today started with the plugin, where you have an iter method. That's the one part of the plugin class that we skipped last time. So this is something that gets a dictionary of iterators. So suppose you're a plugin that needs peaklets, peaklet classification, and merged S2. So that's the peaks plugin. Then you're going to get a dictionary with 3 iterators. So one for each of these plugins. And the basic job of iter is to deal with the fact that these 3 might be out of sync. For example, peaklet classification is likely to be one chunk for the entire run, whereas peaklets will be likely to be one chunk just per original DAQ chunk that was created, or maybe a couple of chunks together in a file. And then pass that on to the actual compute method, where all of the user code is that we've looked at now several times. So that's iter's job. It puts out, see here, it yields stuff. So this thing is called as a generator function, so somebody's iterating over it. And what you yield is either just the result, so that's a Strax chunk that comes out of do compute, right? The user code generally produces an array, but that's then wrapped in a Strax chunk just to note what the start and end time is. Or iter can put out a future. So that happens in case the plugin is parallelized. Strax is always multi-threaded. You can't run it in a single thread. Every plugin has its own thread, but some plugins have more than, some plugins are, say, they're parallelizable. So rather than allocating multiple threads to one plugin, there's a kind of worker pool of threads, and you can submit work to that. So that's what this does. So you submit your function to this thread pool, and then you yield back something called a future, which is basically a small object where you can check, are we done yet? And if so, you can get the result. Of course, iter for the next plugin won't know what to do with that future. That's not part of its job, and that's why the mailbox system will take care of that. That's one of its jobs. So from the perspective of plugins, they can just pretend that, well, they will see iterators that just yield results, but they don't have to necessarily yield results themselves. They can also give back futures. And they're, as they call it, awaited by the mailbox system. Okay, so these yields will, through the mailbox system, either go to another plugin, or they will go, if they're the final one, to the processor. So that's the second part of the reading for this week. So processor is a pretty small class, which basically just is a container for all of these mailboxes connecting the different plugins. There's an iter method that we looked at today, and we'll look at the setup of the processor in the last session. So here you can see this final generator, modulo the mailbox stuff. This is just the output of this yield of the final plugin in the sequence. So the main thing this guy does, the iter of the processor, is just yield from that final generator. And its job is essentially only exception handling, that if in case some exception is thrown here, that because Strax is a multi-threaded program, that all of these other threads also get killed. If they wouldn't, then they would just keep running and your code would hang. That can actually happen. I think everyone had this now. So there is some bug somewhere in the exception handling system. But the idea is that that wouldn't happen, that an exception would be caught, and then it would be fed back to all of the other mailboxes and all of the plugins connected to them, and they would then die. You may see this generator exit thing at some places. So I wrote that you don't have to worry about it, and I think that's true. What basically happens in that case is if there's an exception not in the plugins, but in the user code, so the code that is calling all of this business. If that exits with an exception, we don't get that exception, right? So if you raise an exception in Python, that travels up the call stack, but not to any other object that you may have around. So when you're iterating over some generator, then and somewhere during this for loop you exit, that generator never gets informed about this exception. That's really annoying for us because we would like to then shut down properly all of our threads, but we don't get the message. The only message we get is this generator exit, which happens when Python tries to garbage collect the generator. So when it's sort of shutting down, and it thinks the generator is no longer needed. And then we can still do something. So in this case, we will print some kind of message like, what happened? This is weird, but we will just shut down. That's all this guy does. So it just yields onto another code and handles exceptions. So who is iterating over this guy? That is the context, right? So now we're in getIter, which you've seen before. That's the thing that getArray and getDataFrame are calling. So this guy that sets up the processor, it's doing that here, right? So you set up the processor, and before that it just calls a variety of things. So get components, we'll talk about next week, that gets an instance of all the plugins. There's a little bit part where you're registering a merge only plugin in case somebody requests multiple targets that you can merge together. We actually make a little plugin that will merge them, that we register that temporarily, and we later clean up the registry over here. So this is the guy that iterates over this generator, which is our processor, and its job is only to basically apply selections. It checks that you actually get back chunks. If it's not a chunk, then we die immediately. And it does a little continuity check, which is just, we check that the start of the one chunk is the same as the end of the last chunk. So we're not, for example, accidentally missing a chunk. I don't think I've seen this happen for any good data, but you could imagine some weird situation where it's multi-threading or multi-processing or something, and somehow there's some ordering mismatch. And just to prevent against that, we do this check. You see again this generator exit. So this is actually the case which would be triggered if there is an outside user exception. The other generator exit, which is even deeper inside the processor, that shouldn't really happen because the generator exit is already called over here. Remember, this is a signal you kind of get if you're an iterator and outside in a for loop over that, an exception happens. So it's already called here, and it shouldn't get all the way inside here. And here you see that if an ordinary exception occurs, for example, in apply selection, something goes wrong, then we throw that exception back into our original generator. That's just to prevent the generator exit mechanism from being necessary here. So this is all just because of this multi-threading, that you need to be careful when you get an exception to shut everything down. There could be other ways to handle that. You could define some kind of thread global variable that you constantly check, and that you would register some kind of handler, but this is how we do it. So I think that's all. Of course, that's only the outline. So we can go into much more detail, like what happens exactly inside ITER. And as you saw, there were actually still some issues related to this code. So this code is not bug-free. So that's really I had to say, just in outline. Does anybody have any question on either of these things? And then we can just take other questions related to the same code after that. So who wants to start?
So I'm just looking at the stack of how the final generator, which is I guess sort of the most important object in the ITER function.
Is this the plugin or processor ITER? Sorry.
Processor ITER.
Okay. Yeah.
Yield from final generator, which is a subscription to the mailbox of the target of the first component.
That's right. Yeah.
And the components are, that's just something that the class is given on initialization.
That's right. Yeah. So this is actually defined here. So that contains plugins, loaders, savers, and targets. And currently there can only be one target, but it's implemented so that if we want multiple target support, we can eventually implement it.
So the final generator, which I mean, sort of by its name, is the I guess highest level data that this stack is producing.
Yeah.
So that then very strongly requires that the components have been initialized in correct order. Yes, the first component in the list of components.targets, that one has to be the very final end of the processing chain.
Definitely, yeah. So their target should actually be only contain one element. There's probably a check somewhere in get components that this is the case. I originally had intended that you could request multiple targets. I had some kind of idea that this processing tree of Strax could sort of branch, and you could simultaneously request two different endpoints, say, for example, a muon veto endpoint, a neutron veto endpoint, and a TPC endpoint. Currently, you can't do that. For that, you need to create some plugin that merges them all together. I'll try to find a check.
Plugin.
Yeah, you could. The merge only plugin only works if you have the same data kind. So that will work for if you have a truly branching tree. Let me just find the check for you in context.py. So we have get components somewhere, and I think it's very early here. So if you have more than one target, it just says, yeah, sorry. Oh, it actually says plugins names must be more than one letter because you can. If you make a one-letter plugin, then apparently you can. This sort of mechanism we have for converting a string to a tuple in case it has a length larger than one doesn't work. I don't know. Maybe this exception is out of date, but in any case, targets cannot be more than one element. So this should be okay.
There was the assertion statement right above that check, right?
Yeah, sorry, you're right. So this is really just, okay, so this is the check that's doing that you have only one target. And this is, yeah, it checks that plugin names must be more than one letter. I forget exactly what the problem with that was, but I think we can agree that a single letter plugin is a bad name. Thanks. Okay. So maybe other questions on this this processor part.
Also, I guess line 217. So the mailboxes are started from the top down, or that's kind of a random order.
Yeah, this is pretty much random. But nothing that much happens when the, well, okay, so yeah, you're right. So they're started in, I guess, the random order. We can actually check what happens when you start a mailbox. But I think that starts the iteration over the things. Let's see. So I start the thread. Is this actually, yeah, okay, so so the thread corresponding to every plugin is created in this mailbox process, and there's actually several threads. So there's a thread for the plugin itself, that's the thread where it's writing, and there's a thread for every reading of that plugin. Yeah, and this just starts all of those threads. So that's I think when stuff starts to get spooled. Yeah, I would think so. So that's at least what happens in multiprocessing. We'll get into all of this in the last circle, but in single core processing, it really doesn't make sense to just start randomly pulling all of the data types that we ever need, because there is a pretty specific order in which we want to go through the data, right? The user requests first 10 seconds, and then the second 10 seconds, or it's at least chunk by chunk. And we don't need to first preload like 10 chunks of raw records, since we only have one CPU to work with anyway. So then there's some system which ensures that you only start really loading data when it's actually requested. That's called the lazy mode. But let's get into that in the final session.
I could see, if we sort of philosophical hand wave, the two most sensible ways of starting the whole stack of threads is either from the bottom up or the top down.
Yeah.
The bottom up has the advantage that it's usually a bit more directed. So if so for instance, pulse processing produces 3 different things. DAC reader produces 4 different things, 5 different things, and so if you start at the bottom and work up, then you don't have to then backtrack up other side branches and then start them, or sort of define some arbitrary level. All right, you start at level 17 and you go down. So bottom up would have that advantage, but I could see running into potential issues as opposed to going top down, which only loads data once it realizes that it actually needs it.
Mm-hmm.
So I'm not sure what the best actual way to implement that would be.
Yeah, that's a good question. I've never really thought of this. At least for the single core processing mode, it shouldn't make a difference, since the last thing you describe is what happens anyway. That the first, so there's first sort of the plugins are communicating who actually needs to do something. So you start at the highest level plugin that requests something from the next lower level, then that requests something from still lower until eventually the sort of call to action arrives at the last plugin. But during multiprocessing, you're right. I think this error this order, not error, might be significant. And yeah, we can look at how this currently happens. We go first through all of the loaders. This is in the init. We'll read this next week, but we first go through all of the loaders, everything reading data from disks, and then we go through the plugins. And yeah, then at some point we go through we need to look at how the mailboxes are constructed. Yeah, so in any case, we start with loaders and then do plugins. But then what order that is, that depends on how components is created, and we'll see that next week. That's a good point. I never thought of that.
Because whenever you have, especially once you start multi-threading, whenever you have things starting in random order, it makes reproducing it next to impossible. If there's an edge case where if some thread starts before some other thread, it crashes, and if it starts in a reproducible order, then you can maybe figure out why this one thread has issues, or this one specific function has issues. But if you start in random order, then the chance of actually being able to replicate that bug is next to nothing. Yeah. So the error isn't the order isn't random, since Python dictionaries are ordered since 3.6. But yeah, it is. There's no obvious order to it. That is true. Okay. More questions on this iter in the processor.
I was wondering then from Jelle, what would an issue be in that case? I mean, like the threads must communicate if there is a problem that arises in that case, right? If they don't communicate, where would this edge case come from? That there is an...
I can't give specific examples of edge cases, but I've spent a good deal of time tracing down issues with inter-process communication when things happen in random order, and it's always been absolute chaos and difficult to test and difficult to replicate errors.
Okay.
Yeah, I agree with that. So in the mailbox system, for example, and one of the things the mailbox does is a plugin just produces one output, but it may be needed by 4 other plugins. So it keeps track of which plugin has already read a certain thing, and then at some point it will clean up the mailbox. So if kind of those checks don't happen in the right order, then you can see that you can get a problem where data is deleted too soon, or something else bad happens. We have protections against that. We use things called locks. So there's certain bits of code in this mailbox system you can only enter in this with statement, which basically means no other thread can touch this class. So we've wrapped almost everything in such a lock statement, and then that should give us some protection. But yeah, if I start removing some of these lock statements, then you can get race conditions like Daryl said. We have some tests for it. So test mailbox.py, it tests for all kinds of weird possible things that could happen, but this doesn't test all possible random edge cases that you could get by doing things in weird orders.
Yeah, of course not. This is not possible, I guess.
Mm-hmm.
Okay, thanks.
Sure.
Hey, I have a Python-related question. Could you maybe explain briefly the difference between yields and a generator and yield from, for example, for the final generator?
Sure. So what yield does is it just yields the thing. What yield from does is basically a shorthand for X in final generator yield X. So we could have written this, and that would have done exactly the same. This is not completely accurate. If you go and look at the documentation, there are probably some differences, especially related to coroutines and async IO, but I honestly, maybe I once knew, but I don't remember anymore. So this is basically what yield from does.
Yeah, this is also what I have seen, but I think so in the Stack Overflow communication there, what I found there was, it was especially written that this is not the only reason why this syntax exists. And so I was wondering if this is the reason here or if there's something more to it.
Yeah, I think there's a PEP, so Python enhancement proposal about why they introduced this. So yeah, they start talking about coroutines, and they say, hey, well, you can do it like this, but if the subgenerator interacts properly with the caller in terms of send, throw, and close. So there's these other methods that have nothing to do with iteration. You've seen one of them, throw, in the reading, that you want to throw exceptions to the generator. So I guess in this case, if there was an exception and it wasn't handled, maybe it would be thrown correctly due to the yield from. I think that's the reason, that these other methods, unrelated to iteration, behave more nicely with yield from.
Okay, thanks.
Okay. You guys, can anybody tell me why we're not re-raising this exception here? Why we're doing that later? Seems like an easy thing to do, right? You have an exception, and let's re-raise it. What's the problem? So why are we catching this exception? Couldn't we just let it die? I mean, this is clearly not very important, right? Writing something to the log, which is, just a message on your screen.
Well, that log message tells you why it died.
Yeah, it's nice. So it's nice certainly if the logger is connected to something, but the exception, if we just raised it, that would also tell you why it died, right?
I guess you need to pass it to the other threads.
Yes, exactly. So an exception needs to be, we need to inform everybody else that it died. Otherwise, the threads will keep running. So that's what happens here. We kill the mailboxes associated to this processor, and then we can raise the exception. Okay, but this is still odd, right? Why am I first setting here the exception, then testing here if it's not none? Why don't I just remove this line, and then I'm just handling this exception right here? Why do it in this weird way? So yeah, we need to close the mailboxes. We have some things to do with this exception. Right, so here's part of the answer, that there's something we need to do in between this part and just the end, where you could raise the exception, but that also needs to be done in case everything goes well. So right, we need to call this cleanup in any case. So we have sort of a piece of code that's handled only when there's an exception, then a piece of code that's always called, and then a piece of code again, which is only called when there's an exception. So that's one reason. And here you see the other reason, right? So here's where we actually re-raise the exception. So the exceptions that we get back, they are often sort of an exception wrapped in an exception. So they're often these special exceptions called mailbox killed, which are a signal to the mailbox system that, no, don't worry, mailbox, you didn't crash, but some other mailbox crashed. So we'd like you to shut down, but not generate another traceback on the screen. So we have to unwrap those exceptions and get the original traceback out, re-raise that. And finally, the reason we don't do that here, but here, is that if you re-raise an exception that isn't the original exception, you're not just going to see one exception on your screen. What you're going to get is, hey, there was this exception, and during the handling of that exception, another exception occurred, and that was this exception. So that's going to be quite confusing to the user. So that's why we raise the exception all the way here. Okay. More questions on this processor iter? Okay, then let's move on. So did anybody have a question on the plugin iter?
Again, a very Python related question. Why do you use itertools.count in the for loop? Why not using a while loop, for example?
Oh, yeah, you could. So, right, so you're saying why not do while true chunk plus equals 1, chunk a equals 0. Sure, we could do that. That'd be exactly the same. There's no real reason for it. This
Okay,
might be
thanks.
shorter and fancier, but yeah. Maybe this would have been clearer.
So the bit in iter where it's doing the online, or the live support.
Yeah, that's here.
So we have this hard-coded sleep 2. The DAQ works because of the sleep 2 statement, but because we kind of know a priori what the chunk length coming in from the DAQ is going to be, which is where that specific code is actually going to get called, would it make more sense to have this as a configurable value? Because so rather than you having it wait 2 seconds, and twice out of every 3 times it will do nothing. Whereas if we tell it, all right, wait for 5 seconds, because I mean the DAQ doesn't write more than once every 5 seconds.
Yeah, no, you're right. That would help. The only case is if when the DAQ is writing a lot of data, it might take a substantial amount of processing time to do one chunk. So then it might be just sort of at the same time as the DAQ, and if you then always sleep for longer, then it might be an issue. But sure, in general, whenever there's something hard-coded other than a 0, like here, that could be an option. And so yeah, we could define that. Right, so maybe for those who haven't seen these methods yet, so every plugin also has an isReady and sourceFinished method. So usually you don't define them because you're not an online input source kind of thing, but you can define them, and in that case, this will be activated. So by default, isReady is always true, even though you may not have that data yet, but you can. What this just says is that you could request it. And in case it's not there, then your thread will just go to sleep until it is there. So you can see here, isReady, this returns true. But if you look at the DAQ reader in Straxen, see, isReady. Right, this is more complicated. It says, well, I'm going to check, is the source ended? What are the file paths? And then I'm going to either return true or false. So that's how you make an online input source. You just define the isReady and sourceFinished methods.
So here's going back to my original question, here's a slightly different way we could do it. So if it gets a chunk, then it doesn't sleep. If it doesn't get a chunk, then it sleeps for 10 seconds. Because then if there are chunks waiting, then it just cranks through them as quickly as it can. But if if it's effectively caught up, then it doesn't really need to do anything until the DAQ writes another chunk. Yeah,
I think this is what happens already when so if this is behind the DAQ, then isReady will always be true. So then this thing will never get called and it will never sleep. But yeah, you're right that is necessary. You see also that there's a kind of timeout here, that if you wait for too long, and this is configurable, then at some point you give up. That is one of the many ways in which you can die. Okay. More questions on this? Anybody had a question on this hairy input trimming and chunk splitting part? I'll just ask a question to you guys. So we had a study question here. So what checks are in place to ensure plugins process all data from a run? Can anybody tell me? How do you as a plugin make sure that you get all of the data?
Well, at first, so if you mean if you have multiple inputs, like, I don't know, records and peaklets, for example.
Sure, then you have two checks to do. So you need to ensure that you get all of the records and also that you get all of the peaks.
So iter loops over all chunks. So it starts at chunk equals 0 and it keeps going up until it's out of chunks.
Well, so yeah, it keeps a chunk counter, but it doesn't actually, as far as I know, checks the chunk counters of its inputs. So when it gets inputs through this fetch chunk mechanism, right? So fetch chunk is over here. So that's where we actually get a next chunk from an iterator. I don't think we are not checking that this is the next chunk, or that the amount of chunk numbers equals any total amount, because we don't know at the beginning of the processing what is the final chunk number.
It is in the cleanup, right? That you check whether you have gone through your entire input buffer and stuff.
Yeah, so that's an important check here in cleanup. So at the end of the processing, we check that all the sources are exhausted. So it's not that this thing terminates early. So when you have you've read all of the records, then you must have also read all of the peaks. Otherwise, you're gonna get terminated. It says, hey, we terminated with leftover something. Yeah, so that's one important check. Okay, I think there's at least one more check, but as you go ahead.
Might the other be the stop iteration in the?
In where? Sorry.
Wait, no, never mind. I was
Okay.
mistaken.
So you saw that there could be more checks, right? So we could do additional checks, like check that the next chunk is actually has the right chunk identifier. That would be one more check that we could do. There is one more check in here somewhere. It's relevant to having gotten all of the data. Just get some water. Right, so this check is over here. So I think this is what you meant with the accept stop iteration. So when you fetch a chunk, you want to check that if there's a premature end of the source, you get a problem. You get immediately an error. So this is probably maybe duplicated from the check in the cleanup. If you don't do this, the cleanup would have at some point blocked you. Or maybe the other way around, that if you shouldn't get this. Let me see. So you would get this if when exactly would this happen? That's the problem with these checks, that you can't get them in the normal conditions. So what kind of bug would you need to get this? Yeah, so if the source is exhausted, but the input buffer ends before this time, right? So it's sort of the converse of the check that the cleanup does. So the cleanup checked if you have something left. This guy checks if you end too early. So if some source is exhausted, but the input buffer is over before some time, that's then what another input buffer told you that, well, there is data until this time, then we already know that something is incomplete, and then we're going to crash. So there are quite a few checks to check that the end of the run happens exactly at one time. But there's not that many checks whether there's data missing somewhere in the middle. I think you can, in concatenate chunk, there is one check. So if you try to concatenate a chunk that is out of order, so you concatenate a chunk that actually was earlier to a later chunk, yeah, and it's not going to work. But this doesn't check that there is no gap in between. So what could happen is that through some arcane mechanism, a chunk gets lost here. And in that case, you have still the continuity check in the final iterator that could protect you. But it might be good to also add a check just that the chunk IDs are incrementing. Again, these are just sanity checks. I would be surprised if this is ever causing an issue. But it's nice to have a few of these checks in so that you know that these things are correct and they're not making a problem. Okay, more questions on the iter?
So at the very end of iter, you raise, this cannot happen exception.
Yeah.
So how does iter actually like return? I mean, yeah, it's a generator, but at some point when it runs out of things to do, like it has to stop somehow.
Yeah, you're right.
And it can't do that by getting to the end of its code because that raises an exception.
Yeah, so if there's a break in here, then you die. So there's somewhere there should be a return. Let's see where that is. So here's one way. So in the online input source, the source can be finished. Then we call cleanup and we return. But this only happens for online input sources, so this can't be the only return. So here's the other one. So this happens if the pacemaker chunk can no longer be fetched. And so there's nothing in there. So who can tell me what the pacemaker chunk, the pacemaker input. Who can tell me what the pacemaker is?
The slowest chunk moving through the chain.
Exactly, right? So that's what we determine over here. So the pacemaker is, we just get one chunk from all of my inputs. One of them will be the slowest, and that's the one that will follow. Why aren't we following a random one? So what would be the problem with that?
Because if you return if that one is finished, it doesn't mean that the other ones have finished.
Let's see. Okay, so that could be so. Okay, let's figure out when this chunk ends. Yeah, so that's a good point. So one thing could be just one chunk, but then we should only be calling this if the other chunks have not much more left. Otherwise, we shouldn't be asking for the next pacemaker chunk if there's still something left in the other chunks, because we're going through all of the things that are not pacemakers and asking, hey, you got something? Then please give it to me now, then I can do another chunk. But yeah, I guess you are right that for each pacemaker chunk, there will be only one output of the, or one set of inputs to the next chunk. So that part's right, but I still think if you would follow a random chunk, this logic should exhaust all of the other inputs. That would still work. It's not that this would need to be modified, but I'm not 100% sure. I would have to check. But there's at least one other bigger problem if you would follow a random chunk. A random input, not a random chunk.
I guess you'd fill up your buffers, right?
Bingo, that's it. So if I depend on peak classification, or peaklet classification and peaklets, and I decide to follow peaklet classification, I get one chunk, that's the entire run. So then I'm going to get all of the entire peaklet thing, and that fills up my memory completely. So this is a memory saving device. That's why I'm following the smallest chunk. As with many memory saving things, I pay a penalty in terms of CPU, because it means that I will be pushing computations through this plugin in the smallest chunks. If I'd have instead collected more data, that may have gone a little faster, certainly with something like a neural net, which is this big vectorized computation.
Sorry, I'm now confused. Is the pacemaker now the slowest chunk in terms of processing, or slowest in terms of it's the chunk which spans the largest time range?
Yeah, it's so what we do is for all of our inputs, everything we depend on, we fetch the first chunk, and then we're just going to check who ends first. So what is the smallest time range? So that is the smallest chunk in terms of duration.
Okay, thanks. No, then I got it correct. Thanks.
Yeah. Okay, so just to get back to Daryl's point, when do we end? So we end here when there is nothing more there's no more pacemaker, nothing more in the pacemaker, and the logic after here what that will do is, so, okay, you fetch a chunk from the pacemaker. See where that's actually happening. So you can skip this part. So if the chunk is not 0, then we fetch from the pacemaker. If there isn't anything more in the pacemaker, we end. If you do fetch from the pacemaker, then I'm going to go through all of the other dependencies. And I'm going to fetch until I've run past the pacemaker, or I'm at least at this point. So if you run past the pacemaker, then clearly I don't need to get any more of this, because I only want to fetch the other dependencies until I've got as much as the pacemaker. I want an input of that duration. So you do that. If you get a little bit more, then you need to split the input buffer. And that's where things get a little tricky, because it might be that you cannot split exactly at this chunk end. Why wouldn't I be able to split at this at a random time?
Because you have another dependency where you have a different chunking, right? So it might be that for this other chunk you cannot split there.
Yeah, exactly. So you can't split every chunk at a random time. So why can't I split chunks in general at random times? So what's the problem with that? Just going back to what we discussed earlier.
Because you might be splitting it in the middle of some record or some element in this chunk.
Yeah, so that's the problem. And Daniel correctly pointed out that a specific reason why you hit this is because the pacemaker, you clearly can split at the point where it was actually split. So that's why they come to you in that way. Maybe there's another data type which cannot be split. So what will then happen is it will split a bit earlier. So in that case, then we're going to be trimming the other inputs also. So we're going to check, okay, so maybe we had to split like 10 nanoseconds earlier. So let's trim 10 nanoseconds off the others. But then we get the same problem. Maybe we can't split at that point either. So maybe we then have to trim the others a bit more. And that might cause the rest to be trimmed a bit more. And that can go on quite a while if the data is very dense. So yeah, that's an issue, and I don't really know how to deal with that. So I just try this logic 10 times, and if after 10 times I still don't have something matching, it says, yeah, sorry, we don't get time-consistent input even after 10 passes. So too bad. We're not going to keep doing this until infinity. What tends to happen in practice, I think, with quite dense data and very small chunks, is that at some point it will just be empty. And then one empty chunk will be passed through the processing, and then you grab one more of the pacemaker when you get to the next chunk, and we try the whole thing again. Then it might work, and then you get a larger chunk. So this is one reason why you might get at some point an empty chunk inserted in the middle. It's an empty zero duration chunk, which shouldn't really affect anything. So if anybody has a better suggestion for how to do this, that would be great, but I couldn't think of one. Okay, more questions on this?
Have you ever checked how many passes you need in average, for example, Xenon 1-ton data?
No, never checked. I would guess on average you need 1 pass, but yeah, and then occasionally maybe a second. But that'd be a good thing. It's just to print out here. How often does this happen? Do we already get to like 5 or 6 passes? I don't know.
So Jorn and I came up with a bunch of, I guess, storage-related questions, but I don't want to sidetrack the current discussion unless we get to the end of this. So time to discuss this.
Sure, no, that's great. I think there's only a small bit of code in the current reading about the context. So that's just the iter here. Maybe we can first ask if there's any questions here and then get to your storage questions. Is that okay? Okay, so it's get iter here. So did anybody have a question on the final part of the reading? So the context.py get iter.
Maybe for the progress bar, is there any other way fetching the start time of the very first chunk and the end time of the very last chunk? Is there any other way except for calling get meta? Because this is what I use now, and I wasn't sure if I can get it from some other.
Yeah, I don't.
parameter
Well, you
in
can
there.
get it from the chunks themselves. So every chunk will have a dot start and a dot end. So
Yes, this is what I do to update the progress bar.
Yeah.
But I need at least in the beginning once, if no time range is selected, what will be the start and end time.
yeah, I don't think there's another way. So get meta will go to the run doc, and if it's not there, that means that the run is still running. For example, the end time might not be there. So what you could do in that case is assume an end time that's 1 hour past the start time, since we very rarely take runs that are longer than an hour. But in that case, I don't think progress bar it's very easy if you just don't know when it ends. So I think the answer is no. There's no other way that I know of.
Okay, thanks.
I guess on the topic of the exercises, the idea I had for 222, which would be tracking the computation time per plugin, you'd add probably 2 extra lines to plugin.doCompute, and then just accumulate that up, and then print out at the end. It's like you'd either effectively wrap the whole thing, so you have this I guess per chunk overhead, or you just wrap it around the call to compute.
Yeah, no, I think that would certainly get most of the job done very well. In some cases with multiprocessing, I mean you want to store the result of this somewhere. So I assume you'd store that in an attribute, something like that. That would work, but not in multiprocessing, because then you have several instances of the class.
Can you not just add it as a chunk, additional chunk information to the chunk itself?
Yeah, you could do that. So let's see. Yeah, so the chunk currently has these attributes. Maybe there was, no, at one point there was a metadata here, but at the moment there isn't. But sure, you can add here computation time. You can add here all kinds of stuff. Yeah, that'd be another way to track it. Yeah, certainly. Yeah, so I think that would be a good way to do it. One issue here is that since it's multi-threaded, you can't just measure the wall clock time, but I guess there are ways of just measuring the thread clock time. You can do that. Okay, but yeah, as I wrote here, Jelle is working on trying to replace the backend of Strax with a streams package that would have sort of an automatic dashboard of all kinds of things. And I think, Jelle, correct me if I'm wrong, but that also had a kind of profiling, right?
Yeah, profiling is built into, you get it through the desk dashboard.
Yeah, might still be that we still want a very simple thing inside Strax itself. If it's easy to do, then why not? But yeah. We have, of course, already a way that you can profile Strax. There is in the utils, there is a profile threaded. So you can say with profile threaded and a file name, then it imports this package called Yappy, which it will start a profiler that is thread aware. And sometimes you actually get a useful output. Sometimes the output isn't so useful. I don't know why, but sometimes it just says, yeah, everything is in thread.run. And there are no children. So then it was not useful.
But at least when I've tried to do profiling, I typically am not super interested in breaking it down to the how much time is called in doing this operation, this function. I guess in this context, we'd be most interested in how much time is each plugin taking to do per
Definitely.
chunk.
Yeah,
Which,
because then you know who to blame if it gets slower. Yeah.
Yeah, you know, who's responsible for maintaining that chunk and who gets angry emails from the maintainers.
Yeah. Or who gets very nice congratulatory emails if they speeded up the plugin, of course, because we always do that. All right, any other questions on the context get iter? So yeah, we'll get into this allow shared memory, allow multiprocess later. Or maybe never. This is such a weird stuff.
Yeah, maybe a side question. I think it's in context.py that at some point or in plugin.py, I don't remember. It's probably in plugin.py that at some point you create all these temporary files for temporary classes. But if Strax fails at some point, you just keep on making these temporary files and if you don't pay attention, then at some point your disk is full of temporary stuff until you start reprocessing the same run.
Yeah, so so this is probably in the storage system where we have here. So we create temporary directories. That's not what we do here. So here we just check for them. Let's see. Yeah, so here we have the temp dir name. Yeah, so it's part of the file saving process. So indeed, we create temporary files because we want to do atomic writes, so that as soon as a file exists, it's done and you can start writing it. There's never a case where I need to go back and say, oh, wait a minute, file number 3 actually still contains, also I need to append this. That doesn't happen. But yeah, if then the processing crashes, then you're left with a lot of files, also just files that are not temporary, but just incomplete. I guess they're then in temporary directories, so the directory will still have _temp. But yeah, we don't clean up when that happens. And that is sort of by design, because it could happen that you're taking some very important data and then there's some crash. And then maybe you want to try recover that rather than deleting it and potentially also the raw records. Since we have a very large buffer for live data, that's not really an issue. But at least I think when we started Strax, we had the idea that maybe we could just make 24-hour runs and just start the stream processor and everything would just sort of stream out to DALI automatically and Rukio. We've abandoned that. And still 1-hour runs transferred in blocks, but I think that's sort of the philosophy behind it.
But maybe it's good for others here also to know that you may want to every now and then check your reprocessing folder or something that it's not full of these things. I was actually confusing it with the merge only plugin that is in context. There's also something with temp, but it's something else.
Here. Yeah, so that's right. So when you request multiple targets, it will very briefly create a plugin called _temp_ and then some random strings. But that gets removed immediately afterwards. Yep. So that should be relatively safe. I suppose you could crash and get components and then it would still be part of it. So this is not a very clean way of doing it. You could also get into race conditions again if you would have multiple threads of some user code both calling get iter, get array, something like this, then you could get in trouble here where one thread is adding this plugin that it wants, but some other thread is just calling this and cleaning all of the temp plugins again. So that's again not a very clean way of doing business, but as long as you have one get array or one get iter call, there's no problem.
But one follow-up question on the storage thing, because this was something I was already searching for. Is there any function for which I can check if certain data files were processed with an old version of the plugin. So especially during plugin development, it can happen that you increase the number and increase it. And so at some point I was wondering which files should I delete now? And so I was wondering, is there a function I can say, hey, just look into this directory, which are the old ones?
Yeah, so there isn't one in Strax or even Straxen, but I started a temp data management repo where there is a notebook which contains code which could do that, and one could try to adapt this into a Straxen script. This is of course always the roulette, right? See if the rendering of the notebook works. Let's hope that it does, otherwise I'll open it on DALL-E.
But it's not that you can see this in the metadata of the...
Yeah, it does. This is the code, that's what it does.
Yeah, exactly. You would have to loop over all files and open it. So I was to check the metadata of it. So I was wondering if a function already exists.
Yeah, I'm just going there. So it should be here. Right, bookkeeping. So there's a lot of other stuff in this folder. Now, of course, the rendering is done. Of course. Let's see. Right. So lots of imports. Yeah. So here it's making a list of all the data types that we have. It's getting all of the hashes that are currently requested by this context. And then we're going to check the data on disk. We do it in a complicated way. You could have done, it could have been done much more simple, but I wanted to experiment with data classes. Anyway, so we loop over the storage front end. So there's a raw and a process there generally. You loop over the folders. Yeah, and then you get the hash, see if it's there, or see if you can get the metadata. It's corrupted, it's not available. Is there an exception in it? There's no exception, but the writing didn't end, or it's fine. And then we record that, okay, this is a good data, this is bad data. And then later on, we print that status and you have a code to delete it. So you could use this notebook, just the beginning of it. There's more weird stuff towards the end to do this check.
Okay, thanks.
But maybe this is too complicated for your purpose. If I have a small Strax data directory for myself, I just usually remove the entire thing. That's it. Okay, so we're clearly drifting to our storage. So any more storage questions, bring them on.
Okay, well, so Joran and I had a chat with Amanda on Monday about implementing a supernova trigger. Mm-hmm. So in the case of receiving a trigger, the most likely use case that we were envisioning, or that we were kind of brainstorming, is we would have it set up as some kind of mini analysis. So, you know, there would be a script probably on EV2 that just sits and does nothing until it finds a flag in the database somewhere, and it says, oh, I need to look at, you know, this time range of data.
Yeah.
Now, there's a good chance that this would be sort of a peaklet level analysis. And currently, one chunk of peaklets is 20 seconds.
Okay.
20 seconds real time. This is probably going to decrease as, you know, once single electrons show up, the number of peaklets you generate is going to go through the roof.
Yeah.
But so I would expect the amount of time represented by one chunk to decrease. But that's I guess more of a nuance to this. So sure. Chunks are flushed to disk once they reach the 100 megabyte size limit, the 100 megabyte chunk limit, mm-hmm. For things that allow rechunking.
Yeah. So
it's entirely possible that this signal to do, you know, the signal to do this mini analysis would show up, and the data that it wants to look at is still in memory on whichever event builder is actually responsible for the current run.
Sure, yeah.
So So an idea that we bandied about would be having chunks flush to temporary files to disk. So they would get a 5-second chunk from the DAQ or whatever the DAQ chunk length is. It would it would buffer in memory and then flush its active chunk to disk. And another DAQ chunk comes through, and it would it would increment its buffer in memory and then flush to disk. So that any process, basically to facilitate doing the supernova trigger in this way, so that if it wanted access to data that is still so live it hasn't even hit disk yet in the normal chunking paradigm, so that way it could still actually get access to this data.
Yeah, so you're saying that you need to access this within, and a 10 seconds delay is not, you can't wait 10 seconds.
Potentially not. So the data that is actually moving through Bootstrax is always 2 chunks behind what's actually hitting the PMTs at any one given time. So the DAQ has to buffer 2 chunks. So we were trying to come up with ways to, so the one option would be the mini analysis, looks at the amounts of time, the time range that it's requested to analyze, and then it looks at what the end time of the most recent chunk on disk is. And if it's, if the data it wants hasn't hit disk yet, then it just waits until it is. I guess the implementation gotchas are, we have the advantage that we can buffer data in memory for, many, many, many hours. We can buffer in data for, we can buffer in data for an extensive amount of time before we start deleting things. But not all detectors have this. And so if an experiment wants to save as much data as they can around a potential supernova, they probably want to learn about it as soon as they possibly can.
Oh, you're talking about sending triggers, not receiving.
Both.
Yeah, but okay, for receiving it doesn't really matter, right? We need a long time to write a paper anyway. We're not going to have a paper out in half an hour, so. Yeah.
So the use case here would be, I see Jacques has buggered off. He'd be one person that's actually involved in this. So the use case for this would be, we would receive a low-level trigger. We would look through the data that we have just collected to see if there's something that's, maybe we see, 2 sigma above what we would normally expect for normal. And so then we would contribute to the global snooze level, so this detector saw something, and NTON also saw something.
Okay, yeah.
And this raises the global snooze level, such that other detectors might also start whatever techniques they would use to ensure that the data they would want to do this analysis is available. We have the advantage that as far as receiving a trigger goes, we could receive a trigger a week later and we can just go back to the data and look at it.
Mm-hmm.
Okay, maybe not the neutron beater data, because we only buffer that for 24 hours, but TPC data at least.
Yeah.
But most other experiments don't have this luxury.
Yeah.
And so waiting an additional 10 seconds for this chunk to hit disk might be too late for someone else.
Okay. So in that case, I would suggest maybe not even doing an external mini analysis, with building the check inside the plugin. So when Beaks is processing something, it would call whatever the snooze checking thing is and say, hey, was there supernova trigger in this time that I'm just processing? If so, do whatever. If not, okay, then okay, maybe it would still come later. You would still need your external script. Yeah, if then there would be a small amount of time, you are right, where so the thing has been processed, there wasn't a snooze trigger then. If the snooze trigger appears in the next, what is it, 5 or 10 seconds, then that data wouldn't yet be on disk, but it would be in this memory buffer. So then you would have to wait a little bit longer. But as you say, that since Bootstrap is already behind a bit, so there's only a small window where we would have to wait slightly longer. And for that, you'd have to mess around with, writing this memory, this thing to some kind of temporary chunk file and doing all those things. So you can do it, but it'll only gain you a little bit of less delay in a small part of the possible arrival time windows of triggers.
Yeah, one other thing we thought about doing is maybe just making like a rogue deck reader that as soon as we get this trigger, just starts doing this one chunk and seeing if we could, with this one chunk, see actually something happening just on a different machine apart from Bootstrap that's already running, as that might be quicker because you don't have to wait that long, because you can just, okay, if it's within this time range, do something, and otherwise don't do anything.
Yeah, that's nice, because then you wouldn't have to have two places where the code is called, once inside the plugin and once if the delay comes later. The only disadvantage there is that if you have a plugin that keeps state, it's hard to start in the middle. So I guess for peatlets, that's still fine. All these things can still be parallelized. But if this becomes some event level analysis, then you're out of luck, because there's some stateful processes in between that look at peaks left and right of it. So then you can't start in the middle of a chunk and be guaranteed that you have the same results. That's the point.
We aren't at this point entirely sure what the best way of doing this is. We were basically just banging ideas around and trying to find things that are potentially reasonable, things that are definitely unreasonable. So at some point when we get around to this discussion in the Team A meeting, my guess is, so most of the high-level data is going to fit neatly into one, maybe two chunks. Peaklets is probably the one that chunks the most extensively. It's sort of not a star records type of data.
Yeah, that's right.
But peaklets is going to be like, we plan on storing peaklets long-term on DALI. So we could, we could have larger chunks of peaklets, especially because the larger chunks we end up storing long-term means we have fewer of them. And so computing is less likely going to be showing up in the middle of the night with a baseball bat and trying to kneecap us for, we're already producing, 1,500 files per run. And so as we, computing is probably going to ask for larger, fewer larger chunks. I think 100 megabytes is definitely conservatively small. It's unlikely that you would need to load more than 2 chunks of peaklets into memory at once.
Yeah, I see what you mean. Even if, or it could become an event analysis, and then you do have to wait for a really long time before the chunk is written to disk. That could take half an hour. You may not want to wait that long. Yeah. So in that case, you would need some kind of flushing of temporary chunks to disk. You want to modify the metadata. Yeah.
Or
it could be done, but it's going to take a bit of rewriting.
There's the snooze Strax, which is, as Jorn was saying, this one-off Bootstrax instance that shows up and does it does these specific chunks out of this run.
Yeah.
Whichever say 2 chunks before and 2 chunks afterwards, just so that there's enough so you can deal with overlap.
Yeah, that probably work. At least at the moment, I had imagined at some point maybe doing an exponentially weighted average of some dark counts and using that in the S1 classification. But yeah, I've imagined this for a long time and never done it, so I don't suppose we'll do that. Yeah, so that will probably work.
Yeah, I'm liking the idea more about having this specialized bootstraps instance that basically just does, if a supernova trigger comes through, it spins up on EV2, and then just does its thing.
Mm-hmm.
I am liking that that idea better.
Sure. In either case, there'll be some issues you'll have to deal with.
Of course. The other question that we realized we hadn't really talked about extensively. So records is now a different data type from raw records.
True.
So why do we keep the same chunking?
Why do we keep the same chunking? So if we
could re-chunk to 1 to 4 gigabyte chunks, make them larger, make them chunky, and make them fewer, because records and raw records are the most number of specific files that computing has to track.
Yeah, you could, but then that will cost you CPU and memory, because that means you can no longer parallelize the computation in bills processing. Or maybe you could, but you couldn't parallelize the saving of chunk of records. So this comes back to the parallel source plugin, that everything that can be parallelized will sort of be eaten up together in one massive plugin. And then it will be run once on every chunk, and that can go quite efficiently. If you want this to be a separate thing, if you want to rechunk, then that is a stateful operation. So then everything would be bottlenecked. Every time you save a record, you would go to a single bottleneck. So that could set a cap on the speed of Strax.
Okay.
But maybe that's not so significant. Certainly if we use a efficient compressor, then maybe that just doesn't matter so much if we do a lot of good data reduction. But this is why we don't rechunk concurrently.
Because the average, out of the average hour run, we get 600 and something files.
Yeah. 600
something chunks of raw records.
Yeah, I mean, look, if computing doesn't like it, we can always star them or zip them and then read from that. That's the fallback plan.
Yeah. I'm just looking at what options we have to I guess generate some goodwill with computing.
Yeah, fair enough.
Because DAQ and computing have always not seen eye to eye on stuff, and it's just always been that way.
Yeah, I don't know. It's been. I guess it's like the Dutch and the English, right? There's been a couple of wars, but sometimes one wins, sometimes the other wins. But in the end, they trade a lot with each other and they need each other.
Of course.
Until, of course, the British Empire became really big, and then the Dutch. But that's... All right.
I mean, the easiest thing to do if we have these low data rates is just to have very long chunks coming out of the EQ, right? Then you don't have all these problems.
Yeah,
this is true.
So then if there's a PMT trip, good luck, right?
Yeah, I mean, if PMT is flashing, PMT is flashing, something's going to go dead. I'm pretty sure we'd hit the busy pretty quickly.
That's true. Yeah, would it stay busy until the flash is over? I mean, there's usually some kind of afterglow.
I mean, it stays busy until it's not busy.
Yeah.
So until we've pulled that board's memory out. In the case of a PMT flash, yes, that one chunk is not going to get considerably larger, but
the good thing is that we get from the aggregate status the amount of data Redux has been pushing per second to disk. So if at that point we get the PMT trip, it will show up as the highest rate, and we will lower like Bootstrap's ARM arsenal to be with somewhat less, so that we can still process even with these high data rates.
But that doesn't happen live.
That does happen live. Oh,
does?
yeah, that's true.
No,
Yeah, what you
the
need to do is
mailboxes
change
and
the
stuff.
document.
The mailboxes and stuff is set based on, averages.
Yeah.
Whereas a PMT flash is very strongly non-average.
We based it on the maximum, didn't we?
I think we based it off the most likely conditions for a given mode. So background data is generally going to be around 40 megabytes a second, maybe 50, maybe 30, but it's going to be around 40. During,
No, you're right. We did it on the sum, not the.
if during a PMT flash, the rate is very briefly going to spike up to a large number. And so if records chunks by size, that then kind of saves us, because Bootstrax is probably the only thing that's ever going to deal with raw records itself. And Bootstrax has enough memory to be able to load flash chunks without issue.
Yeah, once the data reduction, once that's all fixed and configured, then I agree. Yeah, but then still, you'd have to rechunk the records, which caps the total speed. But maybe that's not such a concern in background data. There's you can wait half an hour longer to process a run. So yeah, that you could consider. At the moment, records is kind of pointless anyway, because we don't do any data reduction in Enton data. So it's just kind of saving everything twice.
Well, it is quite reduced, right, with respect to raw records.
In Enton?
Because we cut outside hits and all that.
I guess we do something. Yeah, I guess you're right.
I think
I
it's
think
like a factor of 3 or so. If I
Really?
Factor of 2 is the number I usually quote.
Yeah, I know that's for Xenon Wanton data, but I didn't think it would be anything for Xenon Enton. So, but I could well be wrong. Because the biggest data reduction in Wanton data is the high energy veto, and that's not yet activated for Enton data, because we haven't seen any events.
Soon, though.
Yeah.
I hear rumors that they might be Xenon by the end of the week.
That would be awesome.
We'll see.
Indeed. Right, so given that we're closing in on our end time, is there any short question we should do, or should I give a short preview next week and then we...
I think we chased almost everyone away with this discussion.
Oh, really?
There's
Oh,
it's
I
currently
have no idea.
It's currently just Nikev and Freiburg.
Okay.
But Daryl, the number is like 2.5.
2.5, okay.
Difference between raw records and records, or a random run on EV5.
I mean, that's not an unreasonable amount of savings. Not at the amounts of data we're talking about.
Yeah, I guess we're competing with the inference telecom at this point, so maybe that's why we lost the people. Okay, well, do you guys want me to make a short preview next week? I mean, we're going to look at Dataflow, get components. There's, I think, maybe the only example of recursion in Strax, so enjoy it. Yeah, that'll be it. So I guess the next 2 sessions will be like this. Maybe I'll make a short diagram for the final lecture, just because it's mailboxes and it's complicated, but I think we'll survive even without it. Because you have a lot of questions always, so that's very good.
I'm sure I mean, there's more questions yet to come. We just haven't come up with them yet.
Very good. Okay, then let's close for today. See you guys again next week.
Alrighty, ciao, ciao.
Sure.
All right.
Next week.
Bye-bye.
Thanks.